We will welcome Raf Buyle, who will introduce the impact of 5G and the edge on data. Raf is working for he's an e-government strategy advisor, data and innovation at the Flemish data utility company. Good afternoon, Raf.
Good afternoon, and thank you for the invitation. Are you able to hear me well?
Absolutely. We hear you, we see you very clearly.
Okay, thank you. And is my presentation in presentation mode?
It is. It's right
Okay.
up on our screen.
Okay, thank you. Ready for takeoff. So, good afternoon. Indeed, I'm Raf Buyle, and I'm working for the Flemish government in Belgium. Also, I'm a researcher at Ghent University. And I would like to share our insights on the impact of 5G on and edge on data. Also, this research was conducted together with IMEC and the Internet and Data Science Lab. So today, data-driven devices continue to permeate our society. We see all types of new devices enter our homes, our companies, and even smart cities at lightning speed. Now, smart devices such as here in the presentation, Google Nest or Apple devices, which are such some examples of this phenomenon. And what we see is that with this influx of these devices, there has been a shift from more centralized applications to decentralized cloud-connected devices. And we see that the emerge of 5G accelerates this process. Now, what is the problem? We see that on the one hand, we have a privacy and transparency problem. For me as an end user, my data of my vacuum cleaner is streamed to the cloud of the vendor, and it's not transparent what's happening with my data. But also we have an innovation problem, because imagine that I'm working in the agricultural sector and I have a tractor. Also, my data is streamed to the cloud. It's not transparent what the vendor is doing with my data. But also, local innovative companies cannot provide me services that give me more insights in the growing of my crops or other things, because the data is not accessible. There is no level playing field. So we both have a privacy and an innovation problem. But before we look into the future, let's have a look at the past. Now, it's helpful to look at the history of cloud computing. When we look at in the 2000s, cloud computing and centralization increased the efficiency of our applications. By centralizing all the computer resources, we reduced costs and complexity, allowing many organizations, both in public and private sector, to better align their computing efforts with their business needs. Then in the 2010s, we saw the Internet of Things emerge. Everything became connected to the cloud. And we've seen that by then the decentralization started raising questions about efficiency and staying in control of our data. Even efficiency on the level of power consumption. Let me give you an example. When I say like, hey Siri, can you put out the light? I wait for 1 hour and I ask, hey Siri, can you put on the light on again, please? Then the benefit will be zero because the cost of the computing power to put off the light is even more than if the light was there the whole time. So we see that also the cloud computing and the round trip to the clouds causes a huge ecological footprint. Now, we truly believe that now in the 20s, nowadays, that edge is becoming the new cloud because we have many advantages when we are using edge computing. So processing really at on the edge at the level of a sensor or another connected device. But also, besides these advantages, there are a lot of challenges. So what are the advantages? If you have a cloud device that processes the data locally, for instance, in this example of traffic management, you don't need to do the round trip to the server. So this is more responsive. It's more real time. Second, you have lower bandwidth because you process the data locally, and also you have an increased reliability because if the connection fails, in this case, the setup of mobility still will be working and will be able to take decisions. So we see many advantages in the context of edge computing, but as I started my pitch in the beginning, we also have many challenges because if data is streamed to one vendor in the cloud and it's not transparent what's happening with our data, there's no level playing field and data cannot be reused. Secondly, it's not good for transparency. Therefore, in Flanders, we are investing to put citizens again in control of their data, but the same also for companies. So switching from data that is controlled by, for instance, big tech, to data that is controlled by the end user, me as a citizen or me as a business, for instance, in the context of agriculture. So this means that by putting citizens again in control of their data, the value of the data will drop and the value of the services on top of it will raise because companies don't need to put the effort to manage the data or to collect the data. They can just use it when I give my consent. It's more transparent because, as a citizen or entrepreneur, I can decide with who I share my data. For instance, from my data to control the temperature in my living room, or the data from my tractor with who I want to share it. And they can build stunning applications on top of it, which will make my life cheaper, easier, or healthier. In order to do so, in Flanders, we invested in the concept of data pods. So these are personal data vaults, like an online memory stick, which allow you to share your data with applications. So that's on the right-hand side, instead of the left hand, where all data is collected in the different applications, which not only creates a problem, as I mentioned, on the level of privacy and transparency, but also on data portability. Because if I want to reuse my data in other contexts, then my data must be machine readable, so it can be interpreted by other parties without doing manual conversions, because it's not only comes at a cost, but also it slows down innovation. So therefore, our concept of data pods and the personal data space builds upon the principles of the web, of the semantic web, and we ensure interoperability as shown here via the European interoperability framework on the technical level. So we have web protocols which build upon the web that have been there for over 30 years. We have semantic interoperability. It's about vocabularies which ensure cross data space or cross-sector interoperability, and also the ecosystem roles which ensure the interoperability at organizational level. Also, it's not anymore about data sharing, but about collaborating data. We share insights by using AI on the edge instead of sharing all the data. And data on the edge can be trained, so the algorithms can be trained using federated learning, so sharing the insights and algorithms, but not sharing the data itself. So we have been doing tests with Antwerp and Ghent University and IMEC, and we've seen that the technology of Edge is already there. We can improve transparency and innovation by applying the principles we've been focusing on for the past 10 years. So building on the semantic web, so ensuring that data is machine readable and that also consents to share my data can be given at a really fine-grained consent. We have AI, which we can use to share insights rather than the raw data itself. And also, we focus on the principle of the citizen, entrepreneur, or organization in control, sharing their data with who they want to share it, using the data vaults based on the solid protocol. So as a wrap up, the key strengths of Edge, as I mentioned, are higher responsiveness and lower bandwidth. The smaller footprint because it doesn't need a round trip and processing in a cloud data center. We have an enhanced innovation capacity by creating a level playing field where the data is not streamed to the vendor only, but can be reused in other concepts, making my life as a citizen or, for instance, as a farmer more easy. So there, we mitigate the risk of vendor lock-in and the loss of transparency. And in order to do so, we put the user in control using the solid protocol, which built upon the web that we've been using, or web protocols that we've been using for over 30 years. We ensure data portability through interoperability, focusing not only on technical, but also on semantic interoperability, sharing data across data space. And we're using AI to share the insights instead of the raw data, a principle which is referred to as collaborating data. So these are my insights, the insights of our research together with IMEC, Ghent University, Antwerp University, and the Flemish government. And I'm looking forward to your questions.
Thank you very much, Raf. Thanks a lot for being so much on time as well. Yes, we do have questions, actually. The first one is, if data is stored by an individual and under his or her control, is there a risk of creating silos that are not accessible to the general public?
Well, that's a good question. Accessibility can be defined on different levels. If it's about accessibility, can I share my data with other parties? Well, if I have today a device for monitoring the air quality and showing it onto a dashboard in my house, the data will be probably processed in the cloud of the vendor that delivered this device, and I cannot share it. And when I'm in control, I can decide to share this data as public data so that the insights can be reused in my neighborhood or even at a larger scale. The second challenge of sharing data is on semantics and avoiding to create silos by reusing international standards. So in Flanders, we run an interoperability program. It's called Open Standards for Linked Organizations, Oslo, and we've been running it for more than 10 years. And there we have a program to adopt international standards and connect them horizontally across the different data spaces. And we truly believe by adopting international standards, you create opportunities for data to be reused in other contexts, because we've seen that many data portals that publish raw data, the barrier for reusing it is too high. So I truly believe that putting citizen in control on the one hand creates opportunities to share the data in other contexts. And on the semantic level, I truly believe that the way forward is focusing on machine readable data in line with European and international standards.
Thank you. And maybe a bit more briefly, but how do you see the relation between sensitive data and the all-connecting devices of the future?
Well, we see that today, if I want to share my data, for instance, to get advice of optimization of the heat control, the temperature in my house, I need to share all my data. And this comes at a risk because big tech, but also other companies can gain other insights. So in that context, I'm giving away my privacy, but because I don't have another option, or I will be reluctant and it will be a problem for innovation. But by processing this data on the edge using AI and federated learning, I will only share those insights that are needed to or get the benefits of optimization of my temperature in my house, or I can use it for other purposes. So I truly believe that only sharing that data that is needed, so fit for purpose, that it will enable data to flow. And when there's more data, there will be more innovation, and will also stimulate the innovation of our data economy.
Thank you very much. So there are ways indeed of fine-tuning that very delicate relationship. Thanks for sharing that insight with us, and thanks for being with us this afternoon. Have a nice rest of the day, and bye-bye.